Okay, so today we're going to see something I really like. It's the so it's less developer, but the developer will learn some stuff too, I hope. But it's about the evolution of a MySQL database system, and I call this the journey to the MySQL InnoDB ClusterSet. So first, with who am I? So my name is Fred. I'm a MySQL evangelist. I am using MySQL since version 3.20, long time ago. I have seen every solution possible and impossible most of the time to do HA with MySQL. And so this is why at that time I would have loved to see what I will explain to you today. I am a DevOps believer. I like basketball. Latvia has a very good team and they perform very well this summer. I'm living in Belgium and I have a website where if you're interested about MySQL, you can find everything there. I'm running Linux on my machine. Sometimes people ask, so you know. What are the best practices in 2023 in the configuration? So this is something you must have. If you don't, I cannot do anything for you. No, it's not true. But if you are thinking about replication, so who ever heard about replication in MySQL? Some? Okay, good. Mostly ever. So if you are talking about replication, you need to use binary logs. The binary logs format should be raw. Don't use statement-based replication, please. You should use GTIDs. It's time now. They are there for more than 10 years. It's really time to switch to them. The system should be recent. When we play about replication, running that on old system, it's let's say a reason for issues. You should certainly, when you try to replicate to new system and newer system and stuff like that. So let's think that you are using the latest one, 8.035. Who's running 8.035? It was out last week. So this is why, not even last week. Yes, Thursday, or was it already Tuesday only? Yeah. It just came out. Now the innovation release 8.20. Who ever heard about the innovation release? Nobody? One guy? Good. Congratulations, the guy.
Yeah.
So, so when we want to talk about replication, we need to have binary logs enabled, and we will see what to do with all that. So, evolution to HA. This is a small picture. We start there, and we will go there and further, of course. One single MySQL instance. This is where it all begins, right? And but something very necessary is that we only use InnoDB. If you are using MyISAM, who's still using MyISAM? Give me something. I cannot bring you anything because sorry. So MyISAM, you should stop it. It's very bad because MyISAM is not crash safe. Your machine crashes, you lose data. Right, so watch out.
We know this.
So if you need help to migrate out of MySQL, just let me know. I can help you. But InnoDB, it's the only engine you should care about. It's a transactional, ACID compliant, everything, not MySQL. And keep the durability settings on. It's the default. If you have one single machine, so who is using only one single MySQL instance? One guy? Yeah, you just say for the dolphin? Or you should not do that. And certainly, if you do it, keep the durability settings on, because if you crash, you use your data. So on one single instance, if somebody deletes data, gone. The data is deleted. If your hard disk goes away, you lose your data. If your data center or computer goes away, you lose data. If there is a network issue, you cannot connect to your database, it won't work. I hope, no, I'm landed and I don't care, but if this is happened, you lose data. So if there is something happening to your only single MySQL instance, RTO, not existing, RPO, nothing also. So now, and I hope for you, or for your business, the database becomes more important. Losing data might be an issue, right? So you try to not lose the data. So RTO, hours, RPO, 1 day. This is not optimal, but so who doesn't understand what RTO and RPO are? Sarah? No problem. So RPO, recovery time objective. So how long does it take for me to recover if I have an issue? There is an issue, my system is down. How many times do I need to come back online? So here, the next level, so from nothing to something, it's at least 12 hours. I have some hours to come back. And RPO is the recovery point objective. How much data can be lost? So if you come from nothing, like you, sorry, you will be my example today. So if you come from nothing and you want to have something, the first step is 1 day. I can recover to my data like it was yesterday, right? So to do that, what we're going to do?
Backups.
Who said backups the first? It was here. Who said? You got a dolphin. There you are.
Thank you.
So backups. So backups, you can do physical backups, you can do logical backups, right? And for logical backups, who is using MySQL dump? Shame! You should not.
I also use MySQL. What did you want?
MySQL. You will have a dolphin later. You need some love. So MySQL dump, it's old. It's single-threaded to get the data. It's single-threaded to put back the data. Should avoid absolutely. So we have now it's now 4 years at least, even a bit more. MySQL Shell. MySQL Shell is a new client that can do SQL, that can do JavaScript, that can do Python, and you can interact in JavaScript, in Python with MySQL. You can use document store with it without any single line of SQL. I won't talk about MySQL Shell much now, but if you want later we can discuss about that. But with MySQL Shell, you can do a logical dump in one command, dump instance, where you want to do it, how many threads you want to do it, and it's done, it's in parallel, and then you can load it back in parallel. Something, it's not covered here right now, but something you can do, it's you can dump an instance, for example, to object storage, to S3, to something like that from the shell directly. So much nicer, much faster, so it is good. So having a backup, it's already one step of the evolution from nothing to something. So here, this is what we have. If somebody deletes data, you can say, oh, I can put back my data like it was yesterday. If my hard disk crashes, you can restore your data. It takes some hours to restore your data, like it was yesterday. And yeah, if all your data center crash, maybe depends where was your backup. If your backup was in the cloud, no issue. If your backup was on just the machine next to it, it would be a problem, right? So it depends where it is. But at least we have already made a step forward. And so now, let's see if we can go another level up. 1 day RPO, we want to reduce that to some minutes, right? I cannot lose 1 day of data because my business becomes more important. So I want to lose some minutes of data. This is what I agree, but not more. So RTO, some hours still. So if there is a big problem, I have some hours to recover. That we need to, the next step, this is what we have. But RPO, some minutes. I cannot lose more than some minutes of data. So what can we do that? So we need to enable binary logs that will allow me to replay all the modification since the last backup we have done. So binary logs are used for replication, but not only for replication. You can use them to also recover data. You should not do that. Here you can see, because these are the defaults, so you don't need to change them. But log bin, it's on by default in MySQL 8. And sync bin log means it's one. Syncing the bin logs, meaning when you write the bin log, it has to be written to disk. A lot of people are reducing this data these people who reduce that should change hard disk and have some IOPS, right? Because it was 10 years ago, I understand. Now it's time to have a good disk where you can sync data to it without any issue. So now we have enabled the binary loss. With that, we can reduce the RPO to some minutes. If we have an issue, we can recover the backup and then do what's the action? Do you know the name of it? To replay all the binary logs to the point we had an issue, to the point where this guy deleted the data, or to the point we had the crash. Who said point in time recovery? You got a dolphin. you are far, so I can try it. There you are. So it's called point in time recovery. PTI. So this technique, where an administrator will restore the backup and then recover data to a certain point. So with MySQL, the point in time recovery will mean that we're going to restore the dump or the full backup we have, or full backup plus differential backup, or if you're using physical backups with MySQL Enterprise Backup, for example. And then you will need to replay the binary log to a specific point. For example, to the delete where the guy deleted the data, skip that one, that delete, and then come back to all the other writes we have done with it, on the data. So this technique is used to solve an issue, and it's also used to do some to perform some live migration. You want to migrate somewhere, so you have migrate your data, but while your data is working, you still have some extra data to process. You can do the same. So how does it work? So this is what we have now. So we were doing a backup every day, and we are adding data, and so the binary logs has a defined size, 1 gig, 10 gigs, whatever, and when it's full, another one, then another one, and every day we have some binary logs coming. So if you want to recover to this point here, just here, at this time, so what do we need to do? So the first thing is that we need to restore the dump or the backup we had at the day 3. So from day 3 we need to recover all that data. You can notice that every time we do a backup, we flush the binary logs. So when the backup is done, we create a new binary log. Even if this one was not full or whatever, this is the good practice. It's mandatory to do it like that. It's better to process afterward here. So then we replay the binary log, 008, and then we are at that point. Okay, so we need to replay it. So usually we do the backup, and after the backup, and it's verification, because people make backups, never verify them, and after when they need it, they say, oh, but the backup is empty, or the backup, you cannot use it, and this is happening a lot. So here, like I said, when we do, we purge them from the server. So this is what we have in reality. In reality, because the storage on the disk, it's not, you cannot increase that forever. You have the data that already takes a lot of disk space, if you have production data, and we cannot keep all the binary logs there also. So what we do, every time we create a backup, we purge them. We say bye-bye all the binary logs, bye-bye all the binary logs, because we can recover up to here, and then we keep the binary logs of the day. So meaning, where are the points, like this, where are the points that we can recover? We can recover here, we can recover here, because we have the full backup, we can recover here, we can recover here, and recover any time here. But if we want to recover here, that we cannot do that most of the time in production. This is very complicated with the very high data and workload. But we'll see how we can do that after. So now we want to have a next level again, so to increase, because my data is very important, but I have also a heavy workload, a lot of data coming all the time, And I would like to lose less than a second in case of a problem. Not minutes, but seconds now, right? So RTO is hours, and RPO less than a second. What can I do to do that? So what can I do? I can improve the point-in-time recovery. So enable the GTIDs to be sure, but they are already enabled by default in MySQL 8 now. Save in real time the binary logs, because if you crash your disk, the same day, the binary logs are only on that disk, or are on the production server. So you need to stream the binary logs in real time somewhere else. Could be another machine, another data center, or could be, for example, in this is on OCI, in the cloud, in object storage. I stream all my binary logs there. So if I have an issue, I can go back here to bring them back. If you have not used enable GTIDs and you want to enable GTIDs, this is how you can do that. With the MySQL restart, so you do set persist only, GTID mode on. Have you ever seen set persist in MySQL? So set persist is a syntax now that is 4 years old, which allow you to change the configuration of MySQL from the MySQL client. So you don't modify MyCNF anymore. You should try to never modify MyCNF anymore, and you do set persist. If you do set persist, it will change it live and save it for a restart. But some variables like the GTID mode cannot be changed to on if it was off directly. So you do set persist only. It means it will change it in the configuration, and this will be changed only at restart. So you do set persist only GTID mode on, set persist only and for GTID consistency on, restart. You can also restart MySQL D now from the client. Also something new in MySQL 8. And when it restarts, you have it. Now if you say, oh, but I don't want to restart MySQL, but I want to enable GTID, it's also possible. So what you need to do, you need to do set persist and for GTID consistency on. This is okay, this one you can change it whenever you want. But the GTID mode needs to go to off permissive. Why do we need to do that? It's because we are processing transaction at the same time. It's live. You cannot change it from off to on like that. All these transactions coming, and maybe your replica needs to be changed progressively. So what you do, you go for off permissive, then on permissive, and then on. And if you do this step, all the transactions that are in between will be progressively changed to on. And when you are here, it's okay. You have changed it without restarting MySQL, and you can see it took maybe 9 seconds, so it's quite fast. No issue on that. So now we have that. So what we need to do, we need to save the binary log somewhere in real time. How to do that? We will create a user. So I create a user called getBinLog. You give a password, SSL, so you are sure you encrypt the traffic. And then you grant the replication for that user. And on another system, can be a compute instance somewhere that has access to your machine or on one of your server, you do MySQL binlog row read from remote server, stop never, the host, it's the IP where the production server is, which port, which user to use, what's the password, the SSL mode, binlog, blah, 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 from where to start. And we will save, every time there is new bin logs, every time there is new writes in the bin logs, we will save them there. Okay? So now, with this, because we are offloading all these bin logs somewhere else, we have the possibility to restore everywhere we want. So if I want to restore from here, I can. If I want to restore from here, I can. I restore this backup, and then I know, oh, 6 and 7 I need to replay. I will go to the binlog storage here and retrieve 7, 8, 9, 10, and replay everything I need to replay, for example. It's possible. So with that, daily backups and external binlog archiving, we have no RTO from hours, so it takes hours because we need to reprocess all that information. but at least we can lose only up to 1 second max, right? Now, next level, my service is very, very important, and I would like my database to be available again within minutes in case of an incident. I don't want to wait hours to come back online, but just some minutes. So the RTO needs to be reduced from hours to minutes, and of course, RPO, I just don't want to lose data, more data, so we release at less than 1 second. So what we're going to use now, it's InnoDB ReplicaSet. So this is in fact MySQL asynchronous replication, but much easier to deploy. Who is using asynchronous replication? If the people who are using replication? 1, 2 guys? Is it easy to deploy? And how do you, for example, transfer the initial data? How do you do it? Restore from a backup? If you create a new replica, what do you do? Make a dump and then restore. Okay, here it's much more easy. I will show you. And you will tell me, because you know it, so you will tell me, oh yes, it's easy, or no, it's not. Data provisioning is included. That's one thing. You don't need to dump. It will do it for you. You can have 2 or more nodes. There is a manual failover, like now in asynchronous replication. And you can have transparent automatic query routing with the MySQL router. So this is what we create. So we have, with MySQL shell, we orchestrate all that. One source replica, one or multiple replica, asynchronously. So now, here, if this machine dies, we promote this one, the traffic goes to this one, and in some minutes we are back. So this is how we create that. We go on the machine we have and we do, with the MySQL shell, DBA configure ReplicaSet instance. This settings, this command with the latest version 8.2 is not even necessary anymore, because when you do that, it will do that also. It will configure it, so no need to configure it. It will say, oh, I want to create a ReplicaSet. It will say, oh, there is some changes to do in the configuration. I will do it for you. For example, what do we need to do here is to have a server ID different, is to have binary logs enabled, is to have GTID enabled. It checks all that information. So we do create a replica set and give it a name. So we just do that on the machine that we have in production, right? Then on a new machine where we just installed MySQL, we don't do anything else there. So no data, no restore from a dump, no backup restore, anything. We check, we can configure the replica set instance. It will give a different server ID and stuff. And then we do add instance and where is the second instance. And that's it, done. We have not created users, we have not enabled SSL, we have not done anything ourselves. It's all done by the system. So for example, here I run ReplicaSet, configure ReplicaSet instance. It says, oh, there is some changes to do here. And for GTID consistency was off, I will put it to on. GTID mode was off, I will put it to on. Server ID it's 1, I will give it a unique ID. Is it okay for you? Yes. I need to restart MySQL. Can I do it? Yes. Done, and it's prepared. If you don't want to restore MySQL by yourself, you can make the change by yourself with set persist and then without restarting. But here we do it, it's done. Then when we create a new one, it says, oh, I'm adding it. Do you want to do a clone or an incremental recovery? Incremental recovery meaning doing the point-in-time recovery, playing all the binary logs. But we don't know if we have them all. Usually you don't have them all. But if you have restarted by a dump, you could do it. But if you say, oh, I want to clone, it will clone, because now MySQL 8.0 has a clone command that you can clone instances wherever you want. Very easy, and it's very, very fast. Much faster than any restore of the backup. And when, so for example here, it took 2 seconds to transfer all the data, and it's run. And you have now a machine and the replica. So this one is the primary, and now we have the secondary, read-only, this one is retry, and it's created. all automatically with 2 or 3 commands. This command, you can, for example, put them in scripts, or you can put them in some configuration management system like Puppet or whatever. It's possible to do that. And you can see this is JavaScript. You can do it in Python if you want. Also, this uses the admin API that you have in shell. Now on the router, you can say, oh, I want to create a router. You do MySQL router bootstrap. Give one of the machine, of the 2 machines, a user, and it creates, it bootstrap the router, and it provides you 4 ports. This is outdated, and I will show you later why. But by now, 4 ports, one for read and write on this port, read only on this port, and the X protocol. X protocol, it's another protocol, so not using 3306, the MySQL one that everybody knows, but the X protocol, it's used to do asynchronous call, to do document store, to play with JSON and CRUD operation. So you don't do SQL anymore, but you can communicate with MySQL without any single line of SQL if you want. If you are really interested on that, I have plenty of slides on my, you go on my website, and you search for document store, you will find plenty of stuff. And so we have the 4 ports, right? So one, all your writes and reads you can connect to there. If you have read only, you can connect your application for doing reads only there. On the ReplicaSet, you can list the router, and you can see all the routers that have been deployed on the system. Now, if you want to do a manual failover, let's say the machine crash, because we have only 2 machines, because we are using a synchronous application, there is no quorum in it, there is nothing. But usually you don't have that either, because you are using a synchronous application. Then somebody needs to be notified, oh, the machine is unavailable here, it's gone. So what do we need to do? You need to oh, it's gone. Somebody, the operator, need to say, oh, force the primary instance and give another one, the one that is left, to promote it. And then this one can promote it, and the router will send all the information to there. But this is manual, because we are using asynchronous application. Asynchronous application can never be used for a full HA automated system. There are plenty of stuff in the past trying to do that, but they all failed most of the time. So, but finally with ReplicaSet, we have minutes. Why minutes? Because you need an operator to say, oh, this was an error, I need to point to another one. But we lose 1 second, because we have all the binary log, we can do point-in-time recovery, and know that information. So now the next level, my service is very important, and I want to be operational almost all the time. So automatic failover, I don't want that somebody be called or paged by night to change it, and never lose data at all. I want that when I said that my application said it's committed, the database replied to the application, the transaction has been committed, I want to be committed even if I have an issue. How to do that? So RTO seconds now, so from minutes we go to seconds, RPO 0, no loss of data. So what we do, we use another solution called MySQL InnoDB Cluster. It's based on the native group replication. Who has heard about group replication? Nobody? Who has heard about one guy? Galera? More people? It's the same principle almost. Almost. There are some differences. If you want, we can discuss that later. But much easier to implement. And like I said, easier is always better. Data is provisioning is included. If you want real HA, you need to have at least 3 or more nodes. With 2 nodes, it's not okay, because the quorum won't be okay. Automatic failover, it uses also MySQL router, and you can also configure the consistency levels if you want. So this is how it looks like. So now your application can connect to one or multiple routers, and you have the group application here, and you connect to your system. And if something happened to one of your system, somebody else will take over everything. So this is what we do to migrate from the ReplicaSet to InnoDB cluster, we just drop the metadata to say, okay, forget about ReplicaSet. Now we do create cluster. So the machine is the cluster. Here we stop the replication on the secondary node, and we add it. Just add instance, done. Then on the third one, the third machine that was not there, we create it. We just do configure it, add it to the cluster, and it's done, finished. We have a group replication running. 2 or 3 commands, it's okay. We need to bootstrap our router again, so we need to force to modify the configuration, and we use conf use group replication notification, meaning that if there is a change, the router doesn't need to ask all the time about the topology. It will receive the change from the cluster directly, so much faster and less traffic to do that. And this is what we have now. So we have a 3-node cluster. It can tolerate up to 1 failure. What does that mean?
Well, one database can go down.
One database can go down, and why not? We have 3 instances. Why not 2?
Because one is recovering, and when the other one is recovering, you're not going to have replication anymore.
No, yeah, the thing is that if this one crashes, these 2 are running, no problem. But then if another one crashes, they don't know, oh, what's going on? Is it my friend that crashed, or is it me that has been network partitioned? With 2, it's not possible to do that. So if we have 3, you can go up to 1 failure, and when it's done, you need to migrate. If now we have only 2, because we need to fix this machine, and another one crashed, what can we do? We need manually to promote this one and say, oh, you are the only one left. But then you are in a bad shape. But at least it's possible to do. If you have 5, you can have 2 failures. So now, with InnoDB cluster, we have RTO of seconds, RTO 0. We don't lose data, because every time every time the data is committed here, you are sure it has been committed there too. Or will be committed. Let's call it like that. We'll see the consistency after that. So consistency level. By default, the InnoDB cluster operates in a single primary mode, meaning there is only one leader in the system, only one that accepts the writes, and the other 2 are just there for HA. Or you can read to it if you want, but you don't write to them. But the solution has been made. You are allowed to write on all the 3 if you want. No issue. But it's not because you write on all the 3 that you will increase the amount of writes. Why?
Consistency?
No. The thing is that, let's say that we are writing at 100% of the capacity on one machine. More we cannot do, right? We are writing more. And then we say, oh, but I will write on the second one. This second one, like I said, we don't lose data. RPO is 0, right? Because all the 100% of writes happening on machine 1 are already happening on machine 2 also. And they are also happening on machine 3 also. Because the data is everywhere. So every time we are writing everywhere, in fact. So this is why it's a nonsense to write on the 3 nodes, because you will create some overhead that will slow down instead of going full speed. So it's better to write only on one node. But if you want, it's still possible to do that. So what guarantee do we have? We always read the most up-to-date data. To always read the most up-to-date data. To not read stored data, or dirty reads to not happen at all. Can we play with that? It depends on what you need. And you can make some modification globally for the cluster, or only for some sessions. Let's say that you are making a report. You don't care really about the consistency. If there is one transaction not yet there, no need. Now, let's say you are reading some financial transaction. You want to say, oh, I'm sure that everything has been committed before I read that. So for that read, I want to be sure that I'm the latest data. You can change that. So you modify that with the group replication consistency. By default, is the fastest one. It's eventual, meaning that when you write on node 1, eventually, if you read directly, it will be on node 2. Eventually, it means that when you write on node 1, node 2 and node 3 said, I agree to write that data. It's okay. It's certified. Exactly the same as certification. It's a term that you have also in Galera, if you know Galera. You say, oh, it's certified that I will write it. Now, I am writing it. But maybe it will never fail because it has certification, but maybe it's not, the write is not yet finished. So if you read there, it's not there by eventual, right? So, but you can change that. So you can change, I want to synchronize all my writes when I read, or all my writes when I write, or both. So if, as a DBA, I want to load balance all my reads without deploying an additional restriction, or which server I read from, so I want to read off one of the nodes, but I don't want to read stale data, right? What can I do? I will use before. So before I read, I want that when I will do my read, everything is synchronized. I said to the cluster, if I need to wait 2 milliseconds for you to finish the write, I will do. Let me wait a bit, so you pay a big price at read, but you are sure that you read all the data. For a developer, if you want a specific transaction in the workload to always read the latest data, you also do, okay, be sure that I've synchronized before my read. Before this read, I want to be finished. So this is how you do. You do set option consistency before, and then all the nodes have that. Now you can add that in the session. If it's only for a session in your query, you can also do that in your query. After, you say, oh, I want to balance all my reads without any changes, right? But I don't want to read stole data, so I have a lot of reads, but small amount of writes. What can I do? You can say, oh, when I write, this write, I return only when everybody really written. Not say it's okay to write, but they already did. And so I do most of read-only. I just want to write some time, you use write. So all we do, consistency after. And now you can say, oh, I want to be almost the most close of synchronous replication. Something that is very, very close to synchronous replication. So, but I agree to pay the price. You say every read, when I read, I'm sure that all the transaction is done. And every time I write, I'm sure that everybody wrote. It's possible to do that. You do before and after. Yes?
Question, how is the write happening? So if I do, let's say, writes on 2 instances on the primary and one of the standbys, if I do the write on the standby, is it sent to primary first, written there, and then distributed?
No, if you need to modify the mode. So they need, here it's single primary, but you want to use in multi-primary. So if you are in multi-primary, all can accept the write. So you will write data, and all will write, and they're all certified all the time. An example, this is why, for example, if you have a very large transaction, you should not use multi-primary. I will explain. Let's say you modify a big table, and it takes 10 minutes to modify all the records of that table. So you go on the primary, you do update, blah, blah, and you do that. And it starts. 9 minutes already done. 1 minute left. Then on the second, another primary, on the second one, you go and you modify only one record this big one also modifies. When you modify this one will say, oh, I have a modification for this record, and it sends that to the group. The group has a consensus and say, okay, for the number 2 say, okay, no problem for me, because the consensus happened at commit time. So he said, oh, no problem for me, you can apply, I will be okay. Then number 1, he has the transaction processing, but it's not yet committed. He said, oh, no problem for me, you can go, no conflict. Do it, modify it. Then this one finished, and say, oh, I have a conflict, roll back. And this is why, so if you want to write on multiple nodes, you need to be sure to not have this conflict, because we have plenty of rollback. And rollback costs a lot of time in InnoDB, right? So, or if you have a large transaction, just write only on one. Some people, what they do, they plenty of small transactions all the time, multi-primary. When they need to do modification by night, they switch mode to single primary to do all these modifications to be sure that there is no conflict. And all this conflict and all that can happen, it's called a certification. I can spend 2 hours on certification. We can discuss that later, but here it's a bit out of scope. But what you need to do is when you commit, and they all agree to commit, it's committed. And all the other one needs to roll back. This is how it works. Galera is exactly the same.
So it wouldn't introduce a wait or a deadlock, it would do a rollback.
Yes. Yeah, there is no sharing locking between, because if you want to have a locked shared system between all, this will be way too costly. It will cost way too much. So the technology or the process, how it works, it comes from a study, a European study that has been sponsored by the European government for databases. I can send it to you. And Galera used exactly the same study. In fact, the developers who did that, the developers of Galera, were part of the same study. The difference for us is that we use Paxos. They were not using. They were using a token ring to do that. So yeah, you can do, for example, like I said, you can change in the session. You say, oh, for this one, this insert, I want to before and after because this is very specific value, financial, or very important. We can just change it for this insert, and that insert will wait for everything before committing. Right? So now we have the data. We are fine. We can play with consistency if we want. We don't lose data. But what happened in our data center? If no, it's the data center the problem. If there is that plane that crashed on the data center, I have lost all my system. You don't care, you have a single instance, but we need to have a disaster recovery. And this is something very important because people often they make confusion between HA and disaster recovery. It's two things different, right? HA is I have ability, if there is an issue we go up. And disaster recovery is I have a very big problem on my cluster, it's more than expected, I need to have a disaster recovery solution. But disaster recovery means, you hear disaster in it, it means that there is a price to pay at a point. You cannot have free beer all the time. And here we're going to discuss that. But if you want disaster recovery, it's InnoDB ClusterSet this time. So this is the ultimate evolution, right? And it's available since MySQL 8.27. It has fencing in 8.28, and much more you're going to see after that also. So what happened? This is stuff that maybe you never heard about, and it's a pity if you are using asynchronous replication. But we were all this evolution. It's the result of a combination of a lot of work that the replication development team has done in MySQL. For example, we have connection failover. So for asynchronous channel, so if you are using asynchronous replication, when the source dies and somebody else is promoted, you need to reconfigure all your replicas to point to the new one. In MySQL 8.22, this is automatic. You can do that even if you don't use any of these solutions, it's possible. Connection failover is that for group replication. So if you are an asynchronous replica of a group replication, you have also the same. If there is a new primary, you follow it, and it's possible. And plenty of other stuff that we have done. When we put all that together, we were able to create this. So now what we have a cluster here. This is a production. You can have the same environment in another data center. Of course, you can have a group with only one system because it's a disaster recovery. You were going to use only for in case of a big issue. But you can have also the same cluster, and you can. So here, all the machines here are read-only. But for example, if you are in Brussels here and you are in Riga here, you could read here the data, but when you write, you need to go there. But the routers here will point you there anyway. So that will work, it's transparent for you. So this is possible to do, and here there is an asynchronous replication. What does that mean, there is an asynchronous replication? You can lose 1 second of data, and there is no automatic failover because there is this asynchronous link. But if all this crash, I think having somebody to say, oh, put the traffic here, it's still okay to have that manual step, right? But of course you can make multiple, more complex architecture. You can do that also, it's possible. You can do whatever you want and expand that, and I will show you how you can expand that even more. It's all possible. So how are we going to create that? So on the primary instance we add, so the cluster we add, we get clusters just to get back the object, right? We do, okay, now I want to create a cluster set. So I create a new JavaScript object called ClusterSet, and this is the cluster set that I have created. So if I do cluster set status, what I will see just one single cluster into it. And then I say, oh, I want to create a new replica cluster, the one for the disaster, and on that machine, and this will be the name of this cluster. And then on the other cluster, I will add as many instances as I want, and I need to, again, bootstrap the router to tell him, oh, go there, and now you are not the router of a cluster, you are a router of a cluster set. And when we are here, we are safe for every kind of issues that we had, because we are on multiple data centers also. And all that in some JavaScript command or Python command, and that's it. So since MySQL 8.19, we have also DNS-SRV. I don't know if you are using DNS-SRV, but it's possible to use that. And for example, you can replace the MySQL router, because with DNS-SRV, all the topology it's also updated, and they know where to go and where to connect. The connectors know, oh, this is the primary node for writes, this is for reads, all that, you can know that. And now, even more with innovation release. So I don't know if you have heard, but MySQL has changed the way to release. So MySQL 8.0 was, we were releasing new stuff all the time. So now we have decided to go also to support, because customers were asking that, also to have an LTS version. So now we will have a long-term support for some version, and we will have innovation release in between. And so now we have, last week went out the second innovation release. So what we have now with MySQL 8.1, the first innovation release, added read replicas. So you have a cluster and you can say, oh, I want to add read replicas, and directly it will add them, create the replication, send the data, populate the initial data, do the dump, all that for you. And then the router can say, oh, I want to read data. You say, oh, do you want to, you can configure to say, oh, all my reads go to the read replicas, or all my reads go to the secondary. And the read replicas, you can configure all the routes you want, and this is how it works. And so here, for example, all the reads, they are, for example, this one is the replica for one secondary. These two are replicas for the second secondary. These ones, for example, are replicas only on the primary. And if the primary changes, they will follow the primary without any problem. And all that, and all the routes, the router knows all the routes where to go. This was the new stuff we did in MySQL 8.1, so you can configure this stuff very easily. And with 8.2 that just came out, what we can do, transparent read write splitting. So if you remember, before what we did, I told you when we deploy router, we have one port for reads, one port for writes. We, of course, these people were asking that for years. Now it's there. You just have one port, you send the reads and the writes on that port, and we'll change it everywhere for you without any problem. So the router will say, oh, this is a read, I will send it to the primary. Or this is a read, I will send it to the secondary, or to a read replica, this is a write, I will send it to the primary. So all that, you have read-write splitting in the router. You don't need to configure in your application the reads from here, the writes from there. So when you do release the router, we can see, okay, these are all the ports, and there is a new port, read-write splitting port, and you send all that information there. So for example here, I do select port, the member role, in blah blah blah, and I see, okay, I am on port 3330, I'm on a secondary, because I'm not doing any write, I'm not in a transaction, it's okay. Now I want to start a transaction, and not a read-only transaction, so if I check, I go to the primary directly. But I didn't change, I'm still on the same port, and I didn't change anything. I just, in my session, in my MySQL session, or in my MySQL connection, I just do that, and it will go on the right machine at the time. If you like MySQL Shell is also available in Visual Studio Code, so you can do all that in Visual Studio Code also. And yeah, it has plenty of good stuff. So, share your love to MySQL community. There is a Slack channel where I'm most of the time, and me and some other developers, and plenty of people of the community, so if you have questions. Any questions for me? Yes?
Is Java driver supports with read writes magic?
The Java connector will connect to the router. So the router does the read write magic. The router, you have two options. The option we push people, because the router is very small, is to put the router on the application server like an extension of the connector. This is the best. So you don't need to have to think about HA for your router, anything. It's just an extension of the connector. So your connector connects locally, and the router connects where it has to connect. Now other people say, oh no, I want to have a dedicated router on a machine, then you need to do the HA by yourself, or have multiple ones with etcd or whatever. Other question? Yes?
All these new features that you are telling, are they in community edition? Or
Everything is community edition.
Okay.
All community edition.
Very good. Thank you.
Yes?
Can you run MySQL on Kubernetes by using some operator?
Yes.
Cool.
So there is and all this, so not 8.2, it's in progress now, but until 8.1, so the read replica, all that is there is the MySQL operator that for InnoDB Cluster and all the stuff here, it's possible. So you just run the operator, you deploy it, and you can have it. If you're really interested, I wrote a blog post. You can have it on the thread or on Oracle blog, with how to deploy all that in Kubernetes with the operator. So with the operator, it's very easy to do. Other question? Yes?
What are your feelings towards MariaDB?
My feelings about MariaDB? MariaDB is a competitor. I know plenty of people, of good people there in support and in development, because they are my friends. But they're in a bad shape right now. This is what business is, right? There is nothing I can say or do about that. The only thing I can say about MariaDB, and I said that earlier before, is that MariaDB and MySQL MariaDB is not a drop-in replacement for MySQL anymore, since several versions now. So meaning that they are doing stuff that are not compatible with what we are doing, and we do stuff that are not compatible with what they are doing. So at a certain point you need to choose, because you won't be able to come back from one of the other, right? So that's up to you. Now, MariaDB Corporation is a very bad shape financially. I don't know if you have followed the shares and all that story. They are doing layoff a lot. Currently, they are stopping MariaDB Expand, they are stopping SkySQL. So financially, it's very bad for them. Now, but the guys there, the technical guys I know there, are very good guys. I hope they won't be fired or they will choose for, I cannot say if they are looking for a job or stuff like that. We need to ask them. But yeah, for the rest, they do their stuff, we do our stuff, but it's completely different. So at a certain point you will need to choose. Other question? Yes?
For transparent read and write for a single, what's the performance comparison between single port and separate ports for read and write? Does it not introduce waits and locks?
No, of course there is, but if you are using already the router, you won't see any difference, right? Now if you go directly on the machine without going to the router, it's always a bit faster, because here you have the first notification and stuff like that. But you don't care, you have one single machine, right? No, the thing is that performance-wise, 8.2 it's very new. It came out Tuesday, right? So we are expecting more. For my test, but I run some small tests. I didn't see any difference, right? Now maybe it's people on big scale or customers we have, I don't know. I'm not working a lot with customers that we have. I don't know, to be honest. Make test, benchmark it, and I will be very happy to retweet you. And this is how it works, right? People need to check, and but yeah, I don't know. Normally, on our test, on our QA, there was no difference. Let's see. No. One system is never the same than your system, and hopefully for us. But I mean, it depends. Other question? Okay. We're good? In time?
Yeah, thank you.